In today's lesson, we're going to pick up where we left off, and I'd like you to go to the Chapter 15, Lesson 2 notes right here. And then we'll jump right into the presentation. Yesterday, we were answering some questions, and the next question is, in which direction will a static discharge occur? Positive to negative or negative to positive? If you don't remember, go back and watch this video, and it's about the first third into the video that you'll find an answer, or alternatively, you could Google this. Just make sure that when you Google it, you make sure you include positive to negative or negative to positive, or else you get like a low to high answer. And you don't want that. You want to know whether the static discharge is moving from positive to negative or negative to positive. So go ahead and answer that question if you haven't already. The next question is, what might be the effect if a negative charge in a cloud were produced near the upper surface of the cloud? And I'm going to draw you a little picture here to give you a hint. So if there's a cloud here, remember yesterday we talked about how if a cloud has electrons near the bottom and there are protons on the ground, well, the electrons are going to move toward the protons and we get lightning. Well, this time the electrons are at the top of the cloud. So where do you think those are going to go this time? What's going to happen with that? And I drew a little hint there to help out. Yesterday we were looking at current electricity, and today we're going to look at, yesterday we were looking at static electricity, and today we're going to look at current. So as we look at current, we first need to know what current is. Current is the flow of an electric charge. That's important to keep in mind. It's an important quantity in electronic circuits. Current flows through a circuit when a voltage is placed across 2 points of a conductor. So there are several words in there that maybe could be difficult to wrap your mind around. One is circuit, another is voltage, and then conductor. So let's define those words really quick. And of course, we talked about current, it's flow. But when we talk about when we talk about a circuit, we're talking about the flow of electricity. Now, you can probably think of some other words that start with CIRC, like, for instance, circle, right? Or maybe circumference, or circuitous, or circumnavigate, circumstance. They all have to do with round. So when we talk about a circuit, maybe you're thinking of a round path, but it's the path that electricity flows when it goes from its power source and then back to it. It doesn't have to be round. It can be more complex than that. And here's a quick example of a circuit for you, just so you can wrap your mind around it. So this would be a circuit over here. And you can see that it's got a battery as a power source. It doesn't always have to have a battery. It's got a switch that turns it on right here. And then it's got a load, which is the light bulb that's going to use the power. And it's flowing through a conductor. That's one of the other words. So you notice that we also looked at the word conductor. And the wire here is the conductor that allows the electrons to flow through the circuit. Of course, the wire is covered with an insulator to protect you or the person that's using the circuit. And the voltage is just the amount of power that's going through it. So in short, the electric current flows around the wire cable with the amount of power it has. That's what they're really saying. Okay? Flow of electrons. In an electronic circuit, the current is the flow of electrons. And I'm just going to underline that. If you can think of a way to underline that too, I think that'd be worthwhile because that's an important distinction. It's the flow of electrons. It's easy to think that it's the flow of protons because that's the way it's shown. Current is shown in the direction of the positive charges, but that's really the opposite of what's happening here. So it's important to keep in mind. So if we had a representation of that, the electrons is the path of the electrons, I should say, the direction they're flowing is one thing. But we represent the path going the other way, the way of the protons. But the real path of the circuit is the flow of electrons and how they're going. All right, and the last slide to keep in mind here is how we measure current. Like we'd use a thermometer to measure temperature, when we're measuring current, the amount of current, we use something called an ampere. So that's right here. And it's abbreviated with an A or with amps. The symbol that's used for the current is the letter I, the lowercase letter I. Okay? All right, we're going to watch a few videos here. I want you to watch a few videos. And the point of these videos is to illustrate different sources of power other than fossil fuels. So I want you to watch each one. Actually, just to be specific, I want you to watch this one, and then I'm going to have a couple other videos that are BrainPop videos linked below. So watch each of those and be thinking about, okay, first of all, what are each of the sources of electricity? What are the power sources? And then what are the advantages of each? And maybe what are the disadvantages too? I will have all the videos linked below the page. And that is your work for today.